Okay, welcome to lecture 6.8. One issue involved with our scores, scores by me, Levitt, and Snyder. Um, um, let's see, is the following. Let's see. Let me show you something. If this is the scores, say there's only three legislators, one, two, three, and this is say that's your 1991, 1992, two random years, and there's only three people in the legislature, and then suppose they all move 1 point, their ADA scores 1 point higher in the next year. Okay, and there's no turnover at all. Okay, what would our scores do? Suppose they all became one point 1 point more liberal on the ADA scale. Um, if there was no turnover, what our method would do, even if there is some turnover, there's still a problem. What our method would do is say all of this movement, this apparent movement to higher scores, is due to the shift factor. We would say it's due to the scales shifting, that the scales have shifted left rather than the people actually moving right. So our method um, can actually understate or overstate kind of big changes. Okay. Um, uh, Basically, because of some assumptions we make. Now, um, um, this has to do with the XIs and the fact that we assume that for each legislator, his average score stays fixed, or like his ideal point, this XI parameter, is the same thing from year to year. What this basically does is it fixes for all the overlapping legislators, all the legislators who continue, it makes basically their average score has to stay the same from year to year. Now that could be a problem. Maybe they really do move left or right. Now, some people, I'm going to explain why. Maybe I think there's some evidence that that's not a problem. I'll do that in the next segment. But for now, um, um, let me address a criticism that some people have said. Well, what you need to do is you should make XI vary with each year, XIT. Well, if you allow it to change every year, you can show you're not going to be able to identify the XIs. You got to do something, and in fact, I think the program's going to blow up. It's not going to even produce estimates, and the idea is that Keith Poole calls it the glue. That there's nothing to link up the scales between one year and the next unless you have something like either you assume that you have the same issues that are voted on each year from one year to the next. We don't have that. So instead, what we do, our glue, is that we have some overlapping legislators, that we have some legislators who continue from, say, 1991 to 1992, and then we make an assumption about how their ideal point changes from year to year. If you let it be anything, let each one change in any way possible from year to year, you will not be able to link up the scales. So you got to make some assumption, okay? Now, some people have said, well, why not do like nominate? Let it be XIT, but put some structure on it and make it alpha I plus beta I T, something like that. Okay. Um, we could do that. Um, um, but what we argue is that, look, a lot of people say, oh, Poole and Rosenthal, they have this very general form. They allow their ideal point to vary over time. Well, no, they make an assumption to identify their ideal points, they have to make an assumption about how they vary over time. And I told you this is your homework problem. They do something like fix one legislator or fix a few legislators or fix some, or they have to do something in order to identify that. Now, this is one of your homework problems. What the homework problem says is suppose instead that xit equals a constant for person I plus dit. Okay, and now I made this simple. So to make it simple, we assume bt equals 1 for all t. Okay, but then also I just make t equals 0, 1, and 2. There's only 3 years. Okay, and what I want you to do is write the likelihood function. Now before, L just equals pi over I, pi over t, and it equals 1 over sigma phi of yit minus at minus, let's set bt equals 1, minus xi divided by sigma. Okay, so now in your homework problem, what you're going to do is replace the xi with this ci plus dt. Okay, now the first thing to do is, let me give you a hint. So to write this, L equals pi over I, and then replace the t. So the t just goes from 0 to 1. So you're going to do the first case where t equals 0. So it's 1 over sigma little phi yi 0 minus a 0 minus ci plus, let's see, what did I say? Di, that's dit. Di, then t is 0, so that's 0, so you don't have the di. That's all divided by sigma. Times 1 over sigma phi yi1 minus a1 minus, let's just be minus a1 minus ci plus di times 1, all divided by sigma, and then you do times again, fill in another term where t equals 2. Okay, and then I think I maybe even told you you can make, I think, set one of the a's to 0. I can't even remember if I said that. But now what I want you to prove is that this form will not be identified. So basically you can't try to generalize this, make this xit very general. You can prove, I think it's by adding f or 2f to various parameters. You can show that if these are your parameters, whatever parameters you get, there's a way to add something to some of them, subtract something from others, and you get the same likelihood function. So there's no way to identify that. Now that's the problem you are to do on your homework. So the key is, the point is that, so that for our adjusted ADA scores, you can't do something like this. You're going to have to make some sort of assumption. And what we did is we set all the DIs to 0. There's probably something in between you could do, but have some sort of other structure. But just, you can't allow the DIs to be anything. Okay, you have to make some assumption to be able to identify the parameters. Okay, so that is your homework problem. Okay, and I think I'm gonna have another, hopefully, like maybe only 5 minutes, another short segment to explain some of the empirical evidence why I actually think the assumption that we did make is pretty reasonable. Okay, and I'll discuss that in the next segment.